Welcome to JS Media, and today in mathematics we'll be looking at construction. A geometrical construction is an accurate drawing using geometrical instruments. In real life, the word construction usually refers to something that is built, for example, a building, a road, or a bridge. Many people need to be able to do accurate mathematical construction in real life. This includes architects, investors, designers, and engineers. Let us now look at the topic further. So the first thing that we're going to look at is how to bisect a line. And we're going to look at the 5 processes that's going to help us to bisect a line. So the first step that we're going to look at is to draw any line AB. So let us do that. So we have drawn our line AB. That's the first step. Then let us look at the second step. So the second step reads, set the pair of compasses to any length greater than half of AB. So we need to set a pair of compasses that is greater than half of line AB. So let us get our compass. So if we put our compass there at starting point A, then we're going to measure more than half of line AB. So as you can see, that's more than half of line AB. Let us look at the third process. With center A, construct arcs above and below line AB. So using our center A there, we need to construct 2 arcs, one above and one below line AB. So let us do that. So we're going to draw one arc above there, above line AB, and we're going to draw another arc below line AB. Let us now look at the fourth process. With center B, construct arcs to cut the arcs in the previous step at point X and Y respectively. So we are going to put our compass on point B, and we're going to construct arcs above and below line AB. So let us do that. So we're going to draw one arc there above line AB and another arc below line AB. And as you can see, we have drawn our 2 axes there. So we can go ahead, we can name this point as point X and the other point as point Y. Then the last step reads, the line through X and Y is the perpendicular bisector of line AB. So we need to draw a line that is passing through point X and Y. So let us do that. So we're going to get our meter rule. So we're going to put our meter rule there. So the line is supposed to pass through X and Y. So let us draw that line. So the line that passes through X and Y is perpendicular bisector of line AB. So when you do that, that means you have bisected line AB. Where you have questions, please ask them in the group, or you can put them in the comment section. So this is how you can bisect a line. Let us now look at how to bisect an angle. So the first thing that we need to do is to draw any angle ABC. So we need to draw any angle ABC. So as you can see from the diagram, we have already drawn angle ABC. Then the second process, with center B and any radius, construct an arc to cut AB at X and BC at Y. So using our compass there, we need to construct 2 arcs. So we're going to construct one arc starting from point B to cut line AB, and starting from point B to cut line BC. So let us do that. So let us get our compass. So we're going to put our compass on angle B there. So with point B and any radius, we need to construct an arc to cut line AB at X and BC at Y. So let us do that. So we're going to draw an arc there to cut line AB and another arc to cut line BC. So we're going to draw another arc to cut line BC. So we can just indicate these points. So we can put our X there, then we can put our Y there. So we have indicated our X and Y. Let us look at the third process. With center X and Y and using a large enough radius, constructs arcs to intersect at B. So we're going to get our compass, but this time we need to take note that we're going to start at point X and Y, and we need to increase the initial radius that we started with. So we have to increase that. So let us do that. So I've increased the radius. So we need to draw an arc. So let us draw our arc here. Without changing this radius, let us get our compass. We put it at point Y there, and we're going to draw another arc there, and we're going to label this point where these two axes are cutting as our point P there. So let us do that. So let us look at the fourth process. So the straight line BP there is the line that bisects angle ABC. So let us draw that line. So we're going to draw our line BP. So immediately we draw our line BP, that means that we have bisected the angle at point B, or we have bisected angle ABC. So that's how you can bisect an angle. Where you have questions, you can put them in the group, or you can put them in the comment section. We're now going to look at how to draw a locus of points which are 5 centimeters from point A. And for us to do that, we're going to look at 4 steps. So the first step, mark your starting point as point A. So we have marked our starting point as point A. Then the second step, using a pair of compasses, measure 5 centimeters on the ruler. So let us get our compass and measure 5 centimeters. So as you can see, we have our ruler and our compass. So we're going to get our compass there, and we'll start it from 0 and we'll measure 5 centimeters. Okay, we have done that. Let us look at the third step. With center A, using this radius, construct a circle. So with our center A, we need to construct a circle using our compass. So we'll put our compass on point A, and we're going to draw our circle. So let us draw our circle. So we have drawn our circle using 5 centimeters of the compass. Let us look at the last step. The distance from the point A to the radius of the circle is 5 centimeters from any direction, and that step means that if you start from this point A, going to any point on the circle is 5 centimeters, and we can prove that by getting our meter rule. So to prove that, we're going to put our starting point as point A, and we're going to check how many centimeters is it to the circle. So as you can see, it is 5 centimeters. So if we also check in this direction, as you can see, starting from point A to our circle is 5 centimeters, or if we check starting from point A to our circle, it is 5 centimeters. So that's how you can draw a locus of points which are 5 centimeters from point A. Where you have questions, you can ask in the group, or you can put them in the comment section. Let us now look at how to construct a locus of points which are 5 centimeters from line AB. So our first step is to construct line AB, and we have already done that. Then our second step, using a pair of compasses, measure 5 centimeters on the ruler. So we're going to get our compass and we're going to measure 5 centimeters. So we're going to get our compass and we're going to start at 0 there, and we're going to measure 5 centimeters. So let us measure 5 centimeters. So we have our 5 centimeters there. Then our third step, with center A, construct a semicircle arc. So we're going to get our compass there. So starting at point A, we're going to draw a semicircle arc. So let us do that. So we have our semicircle arc. Then our fourth step, without changing the radius, put a pair of compasses on point B and construct a semicircle. So without changing the radius, we're going to put our compass on point B and we're going to draw a semicircle. Then our fifth step, draw a line that touches on top of 2 semicircles. So we need to draw a line that will touch these 2 semicircles. So for that, we're going to use our ruler. So we're going to put our ruler there. Then we're going to draw a line that touches these 2 semicircles. So we have done that. Then our last step, this line represents 5 centimeters from line AB. So the line that we have drawn, this line that is touching these 2 semicircles, it is representing 5 centimeters from line AB. And if you want to prove that, you can get your ruler and you can measure 5 centimeters. So let us do that. Let me just show you. So if we put our meter rule there, as you can see, that's 0 there, then it's coming to 5 centimeters. So that's what the last step is saying, that the line that you draw will represent 5 centimeters from line AB. So where you have questions, you can put them in the group, or you can put them in the comment section. Let us now look at how to construct a locus of points which are equidistant from A and B. So this type of question means how to bisect line AB. So in an exam, you'll be told, can you construct a locus of points which are equidistant from A and B, or which are equidistant from point C and D? So the thing that you have to know, they're just telling you to bisect that line. And bisecting the line, we said the first thing that you're going to do, you're going to get your compass and you're going to measure more than half of the line. After you measure more than half of your line, you're going to put your compass on point A. Then we're going to construct an arc above line AB and another arc below line AB. Then after you do that, without changing the radius, you're going to put your compass on point B and you're going to draw an arc above line AB to cut the first arc that you had drawn using your point A. Then you're going to do the same. You're going to draw an arc below line AB using point B so that it can cut the first arc. Then after you do that, you're going to draw a line that passes through the 2 arcs. That means that you have drawn a locus of points which are equidistant from A and B, or you have bisected that line. So let us get our compass and measure more than half of line AB. So if we get our compass and starting at point A, we're going to measure more than half of line AB. So if we want, we can measure this line. As you can see, it's giving 13.2. So more than half we can get us 8.3. It doesn't matter, you can get 8.5. So as you can see, we have more than half of line AB there. So we're going to construct an arc above line AB, and we're going to construct another arc below line AB. So we're going to have this arc above line AB, and we're going to construct another arc below line AB. After we do that, without changing the radius, we're going to put our compass at starting point B there. Then we're going to draw an arc above line AB, and we're going to draw another arc below line AB. So we have done that. After we do that, we have to get our meter rule, and we're going to draw a line that passes through these two arcs. So we're going to put our ruler like that, then we'll draw our line. After we draw our line that passes through these two arcs, that means that we have drawn a locus of points which are equidistant from A and B, or we have bisected line AB. So that's how you can solve that problem. While you have questions, please ask in the group or put them in the comment section. Let us now look at how to construct a locus of points which are equidistant from AB and BC. So this type of question means how you can bisect an angle, and how we're going to identify the angle that we're going to bisect. We're going to check the letter that is common. So we have AB, then we have also side BC. So our side B there is common, so we need to bisect angle B. And for us to bisect our angle B, we're going to get our compass, and we're going to put it at point B, because we are trying to bisect the angle at B. So with any radius, we're going to construct an arc on line AB. Also, we're going to construct an arc on line BC. So let us do that. So we're going to construct an arc on line AB there. Then we're also going to construct an arc on line BC. You don't have to change this radius. So using the same radius, we're going to construct another arc on line BC. After we do that, we're going to get our compass, and we're going to put it here. We're going to put it on the arc that we had drawn on line AB. Then we're going to increase this radius from the initial radius that we had used. So we're going to construct an arc. Then without changing this radius, we're going to get our compass, and we're going to put it on the arc on line BC, and we're going to draw an arc. So let us draw an arc there that's going to cut the first arc. So we have done that. As you can see, these two arcs are cutting each other at this point. So we're going to draw a line that starts from point B, and it's going to pass through the 2 points where these two arcs are cutting each other. After we do that, that means that we have drawn a locus of points which are equidistant from AB and BC, or we have bisected our angle at B. So let us construct that line. So draw our line. Need to start at point B there, then it has to pass through this point where these two arcs are cutting each other. So when we draw that line, that means that we have constructed a locus of points which are equidistant from AB and BC. So we have questions, please ask in the group, or you can put them in the comment section and I'll be able to respond. Let us now look at types of triangles. A triangle is a type of polygon that has 3 sides and 3 angles. A triangle is a 3-sided polygon having 3 angles. The sum of all interior angles of a triangle will always add up to 180 degrees. This is called the angle sum property of triangle. There are 6 types of triangles with respect to the length of the lines and the angles of a triangle. Let us now look at 6 types of triangles. Triangles can be broadly classified into 2 types, which are: the first one, we have triangles based on the length of their sides. Then the second one, we have triangles based on their interior angles. So let us look at 6 types of triangles. So based on their sides, we have scalene triangle, isosceles triangle, equilateral triangle. Then based on their angles, we have acute angled triangle, obtuse angled triangle, right angled triangle. Let us now look at types of triangles based on their sides. According to the length of their sides, triangles can be classified into 3 types, which are scalene, isosceles, equilateral. So let us now look at the scalene triangle. A scalene triangle has all the side length of different measures. No side will be equal in length to any of the other sides in such a triangle. In a scalene triangle, all the interior angles are also different. Let us now look at the isosceles triangle. In an isosceles triangle, the length of 2 of the 3 sides are equal. So the angles opposite the equal sides are equal to each other. In other words, an isosceles triangle has 2 equal sides and 2 equal angles. The equilateral triangle. In an equilateral triangle, all the length of the sides are equal. In such a case, each of the interior angles will have a measure of 60 degrees. Let us now look at types of triangles based on angles. Triangles can be classified into 3 types with respect to their interior angles, which are acute angled, obtuse angled, right angled. So we'll start by looking at acute angled triangle. An acute angled triangle is a triangle whose all the 3 interior angles are acute. In other words, if all the interior angles are less than 90 degrees, then it is an acute angled triangle. Obtuse angled triangle. Obtuse angled triangle are those in which one of the 3 interior angles has a measure greater than 90 degrees. In other words, if one of the angles in a triangle is an obtuse angle, then the triangle is called an obtuse angled triangle. Right angled triangle. A right angled triangle is a triangle in which one of the angles is 90 degrees. In a right angled triangle, the side opposite the right angled, which is 90 degrees, will be the longest side and is called the hypotenuse. You may come across triangle types with combined names like right isosceles triangle and such, but this only implies that the triangle has 2 equal sides with one of the interior angles being 90 degrees. So that's all about types of triangles. Where you have questions, please ask in the group. Don't forget to like this video and subscribe to our channel. Let us now look at construction of triangles. We can construct a triangle when we have been given the following. So the first situation, when you have been given side angle. The second situation, when you have been given a side angle. And the last situation, when you have been given a side. So we're going to look at each situation in details. So let us start with the first one. When you have been given a side angle, how can we construct our triangle? So let us look at the first situation, how we can construct a triangle using side angle. And we have our question there. The question reads, construct triangle PQR in which PQ is 10 centimeters, QR is 8 centimeters, and angle PQR is 50 degrees. So in that instance, we have been given side PQ as 10 centimeters, we have been given side QR as 8 centimeters, and we have been given angle PQR as 50 degrees. So the first thing that we're going to do, we're going to draw our line PQ as 10 centimeters. So let us do that. So to draw line PQ there, we're going to get our ruler there, and we're going to measure 10 centimeters. So I've measured our 10 centimeters as line PQ. Then we've been told line QR is 8 centimeters. So our line QR, we know that R is somewhere there. So for us to do that, we're going to get our compass. We're also going to get our meter rule there, and we're going to measure 8 centimeters. So we'll get our compass, we'll start at point 0, and we'll measure 8 centimeters. So after we measure 8 centimeters, we have been told that the side QR is 8 centimeters. So we're going to start at point Q there, and we're going to draw an arc up. So we know that our side R is somewhere above here. So we'll draw an arc. Then we've been told angle PQR is 50 degrees. So our angle PQR, we know R is above there, is 50 degrees. So the angle is at point Q. So for that, we're going to get our protractor, and we're going to measure 50 degrees at point Q. So start from inside there. So 10, 20, 30, 40, 50. So we have our 50 there. So we can label this part. As you can see, we have our point there that is representing 50 degrees on angle Q there. So for us to find side R, we're going to draw a line, and the line will start from side Q. It's going to pass through this point, which is 50 degrees. Then it has to touch this arc. So start at point Q. Then it has to pass through this point where we had drawn 50 degrees. Then it has to touch the arc. After we do that, then we can connect to P. Then we can indicate our R there. So we have constructed our triangle PQR, and in this case we are given a side of 10 centimeters. We are given an angle at Q as 50 degrees. We are also given our side QR as 8 centimeters. So let us put our details there. So we know our side QR as 8 centimeters. Then we know that our angle PQR is 50 degrees. So let us measure our length PR there. So if we measure our line PR using our ruler there, so we'll start from 0 there. So as you can see, that's 9 centimeters. So let us indicate our 9 centimeters. So we have our side PQ as 10 centimeters, our side QR as 8 centimeters, and our side PR as 9 centimeters. So we can see that our triangle PQR doesn't have equal sides. So we can name it as a scaling triangle. So a scaling triangle is a triangle that doesn't have equal sides. So we can say our triangle PQR is a scaling triangle. So that's how you can construct a triangle when you have been given a side-side angle. Where you have questions, please ask in the group, or you can put them in the comment section. Let us now look at how we're going to construct a triangle using side, angle, angle. And we have this example that's going to help us. So the example reads, construct triangle XYZ in which XY is equal to 11 centimeters, angle YXZ is equal to 60 degrees, and angle XYZ is equal to 70 degrees. So the first thing that we're going to do, we're going to measure line XY as 11 centimeters. So we have our ruler there, so we're going to start at 0 there, then we'll measure 11 centimeters. Then the next thing we've been told that our angle XYZ is 60 degrees. So we know that the angle is at X there, so we're going to measure 60 degrees on the protractor. So we'll put our protractor at point X and we're going to measure 60 degrees. And as you can see, we have our 10, 20, 30, 40, 50, 60. So we have our 60 there. After we do that, we're going to construct a line that is going to start from point X. Then it has to pass through this dot that we had drawn. So we know that our side Z is somewhere here. So what we're going to do, we're going to draw a line that will start from point X, then it has to pass through this point. So we're going to put our ruler there. So we're going to start at point X, then it has to pass through the dot which shows 60 degrees. Then the next thing we've been told, angle XYZ is equal to 70 degrees. So we've been told the angle is at Y there, so it is 70 degrees. So let us measure 70 degrees. So we're going to put our protractor at point Y. So we have our 10, 20, 30, 40, 50, 60, 70. So we're going to put a dot here. Then we're going to construct a line that is going to start at point Y. Then it has to pass through this dot. Then it has to connect to the line that we had constructed at point X. So we can construct our line that will start from point Y. Then it has to pass through the dot. So as you can see, we have constructed a line that started from point Y, then it passed through the dot, then it had to connect to the first line that we had drawn at point X. So we can name this side as side Z, so we can indicate Z there. So we have our side Z there, so our triangle is complete. So we can input our angles. We know that the angle at X is 60 degrees and we know that the angle at Y is 70 degrees. So as you can see from our triangle, we have labeled angle YXZ as 60 degrees. Then we have labeled angle XYZ as 70 degrees. So now we can measure our angle XZY. So we're going to do that by using our protractor. So we're going to put our protractor at point Z there. So if we measure our angle at Z, we can see this is 10, 20, 30, 40, 50. So that's going to be 50 degrees. So as you can see, our angle at Z is 50 degrees, our angle at X is 60 degrees, and our angle at Y is 70 degrees. So we can prove if this triangle is accurate by adding the angles in this triangle. And we know that all the angles in the triangle have to add up to 180 degrees. So let us do that. So we're going to say 60 degrees plus 70 degrees plus 50 degrees, and that's going to give us 180 degrees. So we can see that our triangle is accurate. So we can finish this triangle by measuring the line XZ and the line YZ. So if we measure our line XZ, that's going to be 13.5. Then if we measure our line YZ, so as you can see, that's 12.5 centimeters. This is how you can construct triangle XYZ when you have been given side, angle, angle. Where you have questions, please ask in the group or you can put them in the comment section. Let us now look at the isosceles triangle. So we are going to use side angle to construct an isosceles triangle. An isosceles triangle is a type of triangle where only two sides are equal. Two opposite angles are also equal in an isosceles triangle. So we have an example of an isosceles triangle. So as you can see, two opposite angles are equal and we have two sides that are equal. So let us look at an example that's going to help us understand this concept. Construct triangle BCD in which BC is equal to 8 centimeters, angle CBD is 50 degrees, and angle BCD is 50 degrees. So the first thing that we're going to do is to construct line BC, which is equal to 8 centimeters. So let us do that. So what we're going to do, we're going to measure 8 centimeters. We're going to start from 0. So we have measured our line BC as 8 centimeters. Then the next thing we've been told, angle CBD is 50 degrees. So we know that our angle is at B. So we're going to get our protractor and measure 50 degrees. So we can count our 50 degrees. We know we have 10, 20, 30, 40, 50. So we have our 50 degrees there. Then the next thing we have been told, angle BCD is equal to 50 degrees. So we know that our angle is at C. So we're going to measure angle BCD as 50 degrees. So for us to measure the angle at C, we're going to say 10, 20, 30, 40, 50. We know we have our 50 here. Then the next thing that we're going to do, we're going to construct one line that will start at B. Then it has to pass through this 50 degrees dot that we had drawn. And we know that our side D is somewhere here. We're going to do the same with the line that will start at C. So it will start at C, then it has to pass through this dot. So let us construct those lines. So the first line will start at B, then it has to pass through this dot that we had put. Then the other thing that we're going to do, we're going to construct another line that will start at C. Then it has to pass through the dot that we had constructed. And as you can see, these two lines are meeting here. So we can say that's where our D is. So as you can see, we have indicated our side D. So we have constructed our triangle BCD. So let us indicate our 50 degrees angles. We know that the angle at B is 50 degrees and the angle at C is 50 degrees. So as you can see, we have indicated our angle at B as 50 degrees, our angle at C as 50 degrees. Let us now measure the length of line BD and the length of line CD. So if we measure the length of line CD, as you can see, that's 6.2 centimeters. So the length of line CD is 6.2 centimeters. Let us measure the length of line BD. So if we measure the length of line BD, that's 6.2 centimeters. So as you can see, our triangle BCD is an isosceles triangle, and we said an isosceles triangle has two sides which are equal. So the length of line BD is equal to the length of line CD. Then the other thing that we talked about the isosceles triangle is that two opposite angles are equal. So if we look at the angle at B is 50 degrees, and that is equal to the angle at C, which is 50 degrees. So we can also measure the angle which is at D, and we know that all the angles in a triangle add up to 180 degrees. And from the triangle, we know that the angle at B is 50 degrees, the angle at C is 50 degrees. So if we do our math, our angle at D has to be 80 degrees. So let us prove that with a protractor. So if we put our protractor at D, we can calculate the angle which is at D. So as you can see, that's going to be 80 degrees. So as you can see, the angle at D is 80 degrees. So that's how we can construct triangle BCD Where you have questions, please ask in the group, or you can put them in the comment section. Don't forget to subscribe to our channel. Using side angle to construct an equilateral triangle. So what's an equilateral triangle? This is a type of triangle that has 3 equal sides. All the 3 angles are also the same. So let us now look at an example. Construct triangle ABC in which AB is equal to 10 centimeters, angle BSC is equal to 60 degrees, and angle ABC is equal to 60 degrees. So the first thing that we're going to do, we're going to measure the length of line AB, which is equal to 10 centimeters. So let us do that. So we have measured line AB, which is equal to 10 centimeters. The next thing we've been told, angle BSC is equal to 60 degrees. So we're going to measure 60 degrees on point A. So we're going to put our protractor at point A and we're going to measure 60 degrees. So we have our 10, 20, 30, 40, 50, 60. So we have our 60 here. Then we have been told angle ABC is equal to 60 degrees. So the angle at point B is equal to 60 degrees. So let us measure that angle. So we have our 10, 20, 30, 40, 50, 60. So we have our 60 there. So we're going to draw a line that will start from point A and it has to pass through this dot. Okay, we have done that. Then the next thing that we're going to do, we're going to draw another line that will start at point B and it has to pass through this point. And this point represents 60 degrees. Okay, we have done that. So as you can see, these 2 lines are meeting here and we can say we have our point C here. So let us indicate point C. So we have constructed our triangle ABC. So we can indicate our angle which is at A as 60 degrees. We can also indicate our angle at B which is 60 degrees. We are also supposed to measure the length of line AC and the length of line BC. So let us measure those lengths. Then the other thing that we're supposed to do, we are also going to measure the angle which is at ACB, or the angle which is at C. So the first thing that we're going to do, we're going to indicate the angle which is at A and B. So we have indicated our angle at A as 60 degrees and our angle at B as 60 degrees. Let us now measure the length of line AC. And for us to measure the length of line AC, as you can see, we have started at 0. So we have 0. If we measure up to our point C there, that's 10 centimeters. So let us indicate our 10 centimeters. So we have measured our length of line AC as 10 centimeters. Let us now measure the length of line BC. So for us to measure the length of line BC, we're going to start at 0. So as you can see, we have our 0 there. Then we have 10. So that's 10 centimeters. So let us indicate that. So we have indicated the length of line BC as 10 centimeters. Let us now measure the angle which is at C, or angle ACB. So as we already know that angles in a triangle add up to 180 degrees. And we know that the angle which is at A is 60 degrees and the angle which is at B is 60 degrees. So if we do our math, 60 plus 60, we're going to have 120 degrees. So for us to find the angle which is at C, we can say 180 minus 120 and we're going to have 60 degrees. So we know that our angle at C is 60 degrees. So if we put our protractor at point C, as you can see, we have our 10, 20, 30, 40, 50, 60. So we can say the angle which is at C is 60 degrees. So let us indicate that. So we have indicated our angle at C as 60 degrees. So that's how we can construct the triangle ABC, and we can say our triangle ABC is an equilateral triangle, and the reason why it's an equilateral triangle is because it has three sides which are equal, then it also has three angles which are equal. So where you have questions, please ask in the group, or you can put them in the comment section. Don't forget to like this video and subscribe to our channel. Let us now look at construction of a triangle using side, side, side. And we're going to use our example to construct a scaling triangle using side, side, side. And our example reads, construct triangle PQR in which PQ is equal to 10 centimeters, PR is equal to 8 centimeters, and QR is equal to 7 centimeters. So the first thing that we're going to do, we're going to measure the length of line PQ, which is 10 centimeters. So let us do that. So we'll start at 0 there, then we have our 10 there. So we have measured our length PQ as 10 centimeters. Then the next thing we've been told, PR is equal to 8 centimeters. So PR, we know that our R is somewhere here. So what we're going to do, we're going to get our compass and measure 8 centimeters. So we'll put our compass there at 0, then we're going to measure 8 centimeters. So I've measured our 8 centimeters. Then the next thing that we're going to do, we're going to get our compass and we'll put it at point P, and we're going to draw an arc here above line PQ, since we know that our R is somewhere here. So we're going to draw an arc. Then we have been told QR is equal to 7 centimeters. So we're going to get our compass and we're going to measure 7 centimeters. So we'll put our compass at 0 and we're going to measure 7 centimeters. So we have measured our 7 centimeters. Then we're going to put our compass at point Q there, and we're going to construct an arc above line PQ. So let us draw an arc. So as you can see, our two arcs are meeting here, and that's where our R is. So let us connect this triangle. And for us to complete our triangle, we're going to draw a line from point P to R and another one from Q to R. So let us do that. So we're going to make a line from point P to R. So we have done that. Then the other thing that we're going to do, we're going to draw a line from Q to R. So from Q to R there. So we have constructed our triangle PQR. So let us now indicate the length of line PR and the length of line QR. So we know that the length of line PR is 8 centimeters and the length of line QR is 7 centimeters. Let us now measure the angle which is at P, the angle which is at Q, and the angle which is at R. So if we put our protractor at point P and if we measure the length of angle P there, as you can see, that's 10, 20, 30, 40. That's going to be 45 degrees. So let us label that. As you can see, we have measured the angle at P as 45 degrees. Let us now measure the angle at Q. So let us now measure the angle at Q, and we have our protractor there. So we're going to say 10, 20, 30, 40, 50. As you can see, we have our 50. Let us indicate 50 degrees at Q. So we have indicated our 50 degrees at point Q. Let us now measure the angle which is at R. So we're going to put our protractor at point R there. Then we're going to say 10, 20, 30, 40, 50, 60, 70, 80 there. And that's going to be 85 degrees. So the angle at R is going to be 85 degrees. So as you can see, we have indicated the angle at R as 85 degrees. So if we add all these angles in triangle PQR, they need to give 180 degrees. So if we say 45 degrees plus 50 degrees plus 85 degrees, that's going to be 180 degrees. So that's how we can construct triangle PQR. Where you have questions, please ask in the group, or you can put them in the comment section. Don't forget to like and subscribe to our channel. Using side to construct an isosceles triangle. So we have an example there. Construct triangle JLK in which JL is equal to 10 centimeters, LK is equal to 10 centimeters, and JK is equal to 8 centimeters. So the first thing that we're going to do, we're going to draw the length of line JL, which is 10 centimeters. So let us do that. So we're going to start at 0 there. Then we've been told JL is 10 centimeters. So we have our 10 there. So we have indicated our length of JL as 10 centimeters. Then the next thing we've been told, LK is equal to 10 centimeters. So LK, we know that our K is somewhere here. So we're going to get our compass and we're going to measure 10 centimeters. So set our compass at 0 there and we're going to measure 10 centimeters. So we have measured our 10 centimeters and we're going to get our compass and we're going to put it at L, since we've been told LK is 10 centimeters. So we'll put our compass at L and we're going to draw an arc above line JL. So we know that our K is somewhere here. Then we've been told JK is equal to 8 centimeters. So JK is equal to 8 centimeters. So we're going to start at point J. So we're going to get our compass and we're going to measure 8 centimeters. So we'll put our compass at 0 there and we're going to measure 8 centimeters. So we have our 8 centimeters. So we'll get our compass and put it at J there and we're going to construct an arc above line JL. So start at point J there and we're going to construct an arc. So as you can see, these two arcs are meeting here and we're going to indicate that as our point K. So we have our K there. Then the next thing that we're going to do, we're going to connect our triangle JLK. So we're going to draw a line from J to K and we're going to draw another line from L to K. So the next thing that we're going to do, we're going to indicate the length of line LK, and the length of line LK is 10 centimeters. Then we're also going to indicate the length of line JK, and the length of line JK is 8 centimeters. So we have indicated the length of line LK as 10 centimeters and the length of line JK as 8 centimeters. The next thing that we're going to do, we're going to measure the angle at J, the angle at L, and the angle at K. So we're going to put our protractor at point J there. Then we're going to say 10, 20, 30, 40, 50, 60. So that's going to be 65 degrees. So the angle at J is 65 degrees. Let us indicate that. So we have indicated the angle at J as 65 degrees. Let us measure the angle at L. So we're going to put our protractor at L and we're going to measure the angle at L. So we're going to say 10, 20, 30, 40, 50. So that's 50 degrees. So we have indicated the angle at L as 50 degrees. Let us now measure the angle at K. So we're going to put our protractor at K and we're going to measure the angle at K. So we can say 10, 20, 30, 40, 50, 60, and that's going to be 65 degrees. So that's how you can construct our triangle JLK, and you can say our triangle JLK is an isosceles triangle, and we said an isosceles triangle has two opposite angles which are equal. So as you can see, the angle at K there is 65 degrees. It's equal to the angle at J, which is 65 degrees. Then the other property of an isosceles triangle is that two sides are also equal. So if we see the length of line LK there is 10 centimeters, which is equal to the length of line JL, which is 10 centimeters. So that's how you can use side to construct an isosceles
triangle. Where you have questions, please ask in the group, or you can put them in the comment section. Don't forget to like this video and subscribe to our channel. So let us now look at the quadrilateral. So the quadrilateral is a polygon that has got 4 sides, 4 verticals, and 4 angles. So we're going to use this example to construct a quadrilateral. So question 1a reads, construct a quadrilateral ABCD in which AB is equal to 10 centimeters, angle ABC is equal to 120 degrees, angle BAD is equal to 60 degrees, BC is equal to 7 centimeters, and AD is equal to 11 centimeters. Then question B reads, measure and write the length of CD. So the first thing that we're going to do, we're going to measure the length of line AB, which is 10 centimeters. So we're going to start from 0 there up to 10. So we've got our 10 there. So we know that's our A and that's our B. Then we know that the length of this line is 10 centimeters. Then we've been told angle ABC is equal to 120 degrees. So the angle is at point B. So let us measure 120 on point B. So we're going to put our protractor on point B and we're going to measure 120. So we can say 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120. So we're going to put our point here. Then we've been told angle BAD is equal to 60 degrees. So the angle is at point A. So we're going to measure 60 degrees at point A. So we're going to say 10, 20, 30, 40, 50, 60. So we've been told the length of BC is 7 centimeters. So BC, so C is somewhere here. So we're going to get our compass and we're going to measure 7 centimeters. So as you can see, we have our 0 there up to 7. So we have measured our 7 centimeters. So the starting point is going to be point B and we're going to draw an arc above line AB. Then we've been told the length of line AD is equal to 11 centimeters. So AD, so D is somewhere here. So we're going to get our compass and we're going to measure 11 centimeters. So we have the setting point at 0 there. So we're going to measure 11 centimeters. So I've measured our 11 centimeters. So the starting point is going to be point A there and we're going to draw an arc above line AB. So we are done drawing our 2 arcs. The next thing that we're going to do, we're going to draw a line from point B there to point C. Then we're going to draw another line from point A to point D. So the line at point B is going to start here. Then it has to pass through this point. Then it has to touch the arc. So we know that's where our point C is. And we know that the length of line BC, that's 7 centimeters. Then the next thing that we're going to do, we're going to draw a line from A there up to D. We know that our D is somewhere here. So the line has to start from point A, then it has to pass through this point up to the arc. So we know that's where our point D is. Then we know that the length of line AD, that's 11 centimeters. Then the next thing that we're going to do, we're going to connect line CD. So I've completed constructing our quadrilateral ABCD. So we can indicate our angle which is at B, and our angle which is at B we have been given 120, and our angle which is at A, that's 60 degrees. So we know this is 120 degrees. Then the angle which is at A, that's 60 degrees. So let us now look at question B. Question B reads, measure and write the length of CD. So for us to measure the length of CD, we're going to use our ruler. So the starting point is going to be 0 there. So if we measure the length of line CD, that's 8.8 centimeters. So our question B, we can say the length of line CD is equal to 8.8 centimeters. So that's how you can construct a quadrilateral. And we have said the quadrilateral is a polygon that has got 4 sides, 4 verticals, and 4 angles. Where you have questions, please ask in the group, or you can put them in the comment section. Don't forget to like this video and subscribe to our channel.